So today we're going to be looking at global consumption and production of energy. So that is both how we create our energy and who has the most energy, particularly in terms of resources, and our consumption of energy, who uses the most energy. Now, today's lesson is all about patterns, global patterns in production and consumption, as well as thinking about the reasons why some places have more than others and what the impacts of these differences are. Our key skill today, and something we're going to practice all the way through the lesson, is understanding graphs and using data. It is an absolutely key skill for geography students, and it's one that some of you guys don't feel very confident doing, but you'd be shocked at how many marks there are in the exams that just come out of being able to read data off a graph and express it again in your own words. So, starting with the basic premise, humans exploit or use the Earth's natural resources, and in particular, this whole unit is about energy resources. Today, we're going to talk about fossil fuels as well as renewable energy resources, but this picture I've got here is about how fossil fuels were first created. Now, bearing in mind that this process takes millions of years, okay, what happens over time is that in our deep oceans, or even where we've had forests on lands, the organisms that lived in those oceans, which have hydrocarbon bonds that make up their bodies, just like you and I, which have amino acids, which are made of hydrocarbon bonds, which make up our muscles and make up our bodies. We are, organic chemistry ourselves. All of those organisms falling to the bottom of the ocean, or remaining on the land and being compressed down by increasing layers of sediment that layer on top. So that deposition that we talk about when we do coasts and rivers is really, really key to the formation of these fossil fuels. So the layering up of the sediments on top mean that the organisms effectively become fossilized and they turn into oil and natural gas. And now, millions of years later, we are able to drill down through the layers of rock and sediment and find the oil and gas that's been trapped underneath the surface. So the Earth itself has a wealth of natural resources, loads and loads of things that humans love to use. And these natural resources, like water or coal or gold, have allowed the human population to grow and develop. But the places where we find these resources is not equal. It's not the same everywhere. Some places, which for instance used to be ancient seas, will have more oil and gas resources, and other places will have far less. Of course, in the same vein, if we're thinking about our renewable resources, well, some parts of the world are a lot windier or receive a lot more hours of daylight and are therefore more suited to those particular sources of energy. So, they're not equally available in all countries, and that is the basic point of today's lesson, that we are going to look at what the differences are through some patterns. A reminder, before we go any further, that you should have a worksheet that looks just like this. And throughout today's lesson, I would like you to make sure you are filling in your answers on your worksheet. Okay. So, of all the fossil fuels which are produced in the world, the United States produces 20% of them. Now, that is really significant for just one country to produce a fifth of fossil fuels. And you're going to hear the United States mentioned a lot of times today. But they are not by any means the only country that produces these energy sources. There are lots and lots of others to mention, but they're probably one of the most significant energy producers in the world. Russia and Iran are also in the top 3 of energy resources. After that comes Canada, which is just about 5% of all fossil fuels globally. Now, what I haven't included in this first fact is about renewables, but we will get there, don't you worry. So our first task then, you're going to answer these questions for me, and I'm going to take you through a timeline, if you will, of energy use per capita. So our first map today then, chloropleth map, and this kind of map shows you data based on each country, and it'll show you data on a scale which is color coded. Normally, the darker the color, the higher it is on the scale. And in this case, we're talking about how much energy do these countries use. And you must be very careful because it does say energy use per capita. Hope you know what per capita means. See if you can remember. Okay, it means per person. Okay, so per capita, and we're saying per person per year, effectively. So per capita refers to per person. So we're going to go through these. I'm going to ask you to answer these questions. What did we just say? How can we tell from the map which countries use the most energy? Answer your first question now, please. Okay, and you'll see that this first map that I've got here is from 1960. And we are going to spot the differences as I move us through the years, please. So, second map, 1970. And now we've got a lot more data in this map. In the first map and in this one, there are still a lot of countries that are coloured grey. What does that coloured grey mean? It means that we actually don't have data that dates back to that. So if we look at our key down here, we can see that there's no data. So answering question 2, please. No data means, or grey colours mean no data, meaning that we don't know how much energy they were using at that time. To be honest with you, even in 1970, some of these figures might be estimates, okay? Or they may be partially estimates and partially based on data, say for instance, about how much coal was being used then. It isn't that long ago, we're still only talking about 50 years ago, so, we should have some data, but maybe not complete data, particularly for places like Madagascar, or Papua New Guinea. So we'll keep going. What do you notice about countries? So firstly, what was the difference between here and here? What happened to most of the countries? Hopefully you noticed they actually got darker, okay, which indicates that their energy use per capita is going up. 1980, 1990. So again, getting darker. 2000, 2010, 2015. Now, we've still got countries where we don't have data. Perhaps it's not very reliable data. Perhaps the government doesn't want to publish it in those places. But we have a pretty complete picture here. Now, I'm going to ask you, from this 2015 data, how much energy would you say Australia uses each year? What's the sort of rough number that we would work out from that scale at the bottom? So if we're looking at Australia down here, you should be able to spot that the colour is pretty much a match up here. Okay, and we're talking about 75 kilowatt hours per person per year. That is a huge amount of energy. It's actually higher than the amount of energy that we would use in the UK, which is somewhere around 50 kilowatt hours per person per year. Okay, not as high as somewhere like the USA instead of the United Kingdom. Do you notice any kind of patterns here? Which countries appear to have less energy use per person per year, and which countries appear to have more energy use per person per year? If we have a look at which some of these countries are. So we've got the United States, we've got Canada, we've got most of Europe here, including France, Spain, the United Kingdom, Germany. Then as we go further north, we have Sweden and Norway, Russia up here. Why might Sweden, Norway and Russia have higher energy consumptions than other parts of Europe where they've got similar levels of development, particularly Sweden and Norway, and say Germany and France and the UK, pretty similar levels of development? Why would they need more energy? What might be different in those places? Okay, hopefully you realise that the further north we go, the colder it gets, and a large amount of our energy use is, of course, in heating our homes. Okay, it's not just for things like transport or just for charging our computers or our electronic devices or making machines work, although those are really important uses, but also simple things like heating our homes. Now, here's one thing. If a lot of energy around the world is used up by making things, manufacturing things, why does it appear, this is question 4, why does it appear that China uses less energy than the United States of America? Why is it that even though we know huge quantities of goods are produced in China every year, that they appear to have less energy use than the United States? Well, the clue to this answer is in fact back in our title. When we said it was energy use per capita, that means we're dividing the total amount of energy that country is using by the number of people who live there. And that changes the data quite dramatically because, of course, China has a large population, a very large population of over 1 billion people, and that helps to bring down its per capita energy use. If we looked at it just as what's the total amount of energy that China and the USA use, you'd probably find that they are both really, really high and probably not that different from each other. So my final question then for these maps here, this choropleth map here, I'm just going to take us back a couple. Our final question is overall, did world energy consumption rise or fall? So as we go through these stages of the maps and the colours get darker, hopefully you can tell that that means that energy consumption is rising, and it's rising dramatically. Okay, partly because of the spread of technology, but also as people's lives get better, as countries develop and their quality of life improves, that comes with using more energy. Think about all the things that make your life really nice to live and make it what we might call a modern way of living. You have electric lights in your house. You might have heating or air conditioning in your house. You've got a stove that you can turn on and off whenever you want. You've got electricity to power not just the lights, but also your devices. You've got transport to be able to get around. All of those things require energy. So as countries develop and people's quality of life improves, that requires more energy. And one thing that you will notice here is that amongst the poorest countries in the world, particularly in sub-Saharan Africa, that means just underneath the Sahara, sub being under, like submarine, sub-Saharan Africa has amongst the lowest energy use per capita. Not just because they are relatively less developed, but also because they have less access to these energy sources. Now, two little things to point out. One of them is that this country here has an incredibly high energy consumption per capita. Now, I wonder if you know which country this is. A lot of people get the countries in this area confused. You might be tempted to think it was the United Arab Emirates, but you'll see that although they are the same colour, that is a tiny little country there is the United Arab Emirates, much smaller. This much larger country is Saudi Arabia, and Saudi Arabia actually has very few people in it relative to the amount of energy that they use, and that makes their energy use per person or per capita very, very high. It might also be because energy in Saudi Arabia is very, very cheap. And we're going to look a bit more at why it's so cheap in Saudi Arabia to use energy, because they are also one of the world's largest producers of energy. So here in this map, we've been looking at energy consumption, how much energy we use. And next, we're going to be looking at energy production. But before we do that, we want to just explain something. From the images below, why is it that our African countries have amongst the lowest energy consumptions? So what types of energy are getting used? Why might they not need as much energy right now? That doesn't mean in the future that they won't need energy, but just right now, why are they not using that much energy? And the opposite of that, why is it places like Canada, the USA, and Australia have super high energy consumption? Remind yourself using these images. Okay, so hopefully you might be saying that a lower level of development means that more people are likely to cook their food over open flames using biofuels or wood rather than having gas into their homes. Perhaps there are fewer sources of major power plants available. Perhaps there's a lower level of development, or in the case of somewhere like Canada or the USA, high levels of development, lots of demand for energy, and in particular, high demand for energy to heat or cool our homes. We might be thinking about the population size. Again, remembering that these numbers are divided by the number of people. So you could have quite a high consumption of energy, but if you have loads of people, it will come up as a lower number. And finally then, thinking about the types of technology, okay, even in our food production in the UK or in the United States of America, you would find a huge amount of technology used to produce food, whether that's tractors, pumps to irrigate fields, combine harvesters to take the crops out of the fields. You wouldn't necessarily be seeing it being done manually as we do in this image. And of course, this is much more low intensity in terms of its energy consumption. So, I've spent a lot of time talking, and I'm going to ask you now to practice these three concepts. So we've talked about this a little bit. I'm just going to make it really clear on the board. Okay? Economic development is something that changes how much energy we use. As a country gets richer and more developed, people's quality of life improves, and the amount of energy they need in their everyday lives goes up. Okay, so it's a vital thing for growing economies. Depending on the economic sector, our energy uses change with our job types. So, for example, lots of people working in agriculture don't require as much energy, for instance, as IT sectors, where the IT sector consumes huge quantities of energy, not just to power the computers, but also the storage, the data storage centers, the cooling equipment, all of that kind of thing. And then you've got to think about what types of fuel sources there are. If you're using a traditional rural fuel source, as you might be in a developing country, although there might be plenty of energy resources available, if you've got no choice but to burn wood because there isn't a power station nearby, then actually that's all you can do, and you end up using less energy as a result. So here's our practice then. 2 exam questions. You have them on your worksheet as well. They're not very long answer questions, but they use the knowledge I've just discussed with you. Now, these 2 questions in the exam, they came with this map. Now, we've already looked at a map showing the same kinds of data, but it is always useful, of course, to have that there. Now, the question said, compare the amount of oil consumed in Mali and the USA. And you need to know that Mali is a sub-Saharan African country. So Mali is this country here, amongst the lowest oil consumption. And of course the USA is over here, amongst the highest consumption. So I want you to compare them, and you need to use, in this case, the figures from the map. Okay, it's a 3-mark answer. You're making a comparison, so you want to make a point, give some evidence, and then explain it. Okay, and then particularly question 2 is all about those reasons. Explain. So maybe the first one, we do a point and 2 pieces of evidence. And the second question, we're explaining. Give yourself 5 minutes to do this. Pause the video now. Okay, so we're going to look at some answers then. And our answers can be quite varied, but they do need to make specific reference to the map. So your first point should of course have been that Mali consumes far less oil compared with the United States. Mali over here, the United States over here. Okay, so that's your first point. Got your first mark. Okay, you notice that on the map, this is way lower than this one. Okay, and it's lower, we know, because it's a choropleth map and the scale tells us so. Then we're going to get our first piece of evidence in. The USA consumes more than 10 million barrels of oil per day. More than 10 million barrels of oil per day. Now, one easy mistake to make in this example is that you might read it here and it says above 10,000, but you have to look at the units because the units are also in thousands. So 10,000 is actually 10 million barrels of oil per day. Okay, so over 10 million barrels of oil per day, whereas Mali consumes less than 10,000 barrels of oil per day, below 10,000 barrels of oil per day. Not less than 10 barrels. You've got to think it's an entire country, yeah? They're not going to use just 10 barrels of oil a day for, over 1 million people. That's not going to work out. So be very careful with your units here, please. Finally then, if you didn't get one of those two pieces of evidence, you could have had something to say the USA is one of the highest consumers of oil, whereas Mali is one of the lowest consumers of oil. We could have done the first and the second point, maybe with any other country that has less than 10 million barrels a day being used. But actually, these two countries are really, really far apart, the opposite ends of the scale. So that could have been your fourth point. Okay, so 4 things that you could have said to get those 3 marks. You don't need all of them, you need 3 out of 4. Just double check your answers. Right, second question. Suggest one reason Mali has lower oil consumption. And here, this is where we're testing what we just talked about. Why does Mali have lower oil consumption? Well, you might have said it's a developing country. It has a lower GDP, it has less wealth to pay for that energy, and the majority of the workforce are in the primary sector. And that means that they actually have less demand for oil. That doesn't mean that they will never have higher demand for oil, but right now, with what they're doing, they have less demand for oil. So you might have said it's a less developed country and there's not enough demand. For example, lots of people don't have cars in Mali. A lot of people will be traveling on foot or by bike. So task 3 is a gap fill. For this slide and the next 3 slides, we are going to be doing that gap fill. On your worksheet, it looks like this. So you're filling in the yellow spots on here. And we are looking at an unusual type of graph now. It's what we call a cartogram. So it starts off with the world map, as you can see there, and it transforms by changing the size of the country based on the data that we're looking at. In this case, we're talking about how much oil is being produced by that country. So let's have a look at some places that disappear and some places that seem to grow when we apply the data. So you'll notice that much of Asia and Northern Europe kind of disappears. Pretty much all of Africa disappears except for here, Ghana and Nigeria in West Africa, where they actually do have quite a lot of oil reserves. The USA grows significantly, and that reflects the fact that they are the world's largest producer of oil, and in fact all fossil fuels, but they produce 18% of all the oil that is produced in the world. Now, just because they're producing a lot of oil doesn't mean that they have a lot left. When we talk about how much energy a country has left, we use the phrase reserves. So we're talking about energy reserves are what they have left, just like you would in a sports game. If you keep someone in reserve, you're holding them back, you're going to use them later when you need them. It's the same thing with energy reserves. So energy reserves, in the case of oil and coal, are the energy that remains in the ground that you haven't dug up yet, you haven't extracted yet. A couple of other places that are notable on here then. The United Kingdom actually produces quite a lot of oil through drilling in the North Sea. Venezuela is a country here in South America which has a huge density of rainforest, high biodiversity. It's still a developing country, so it's not very wealthy. But underneath all of that incredibly valuable rainforest, they also have amongst the largest oil reserves in the world, the largest amount of oil remaining. And so their government and their people have a very serious dilemma on their hands as to whether or not to exploit those oil reserves to earn themselves some money or to allow the rainforest to be preserved. And a bit of a difficult choice because the choices that locals and governments might choose to make may not be in the interest of global environmental sort of sustainability. The last thing is something that maybe you've noticed as you've watched this kind of mesmerizing GIF map changing. But we've got this area in the Middle East which expands dramatically. And this is basically the Arabian Peninsula and the Middle East. Now, the Arabian Peninsula is made up of lots of countries, but in particular, Saudi Arabia is this large yellow one here, and it is the world's second largest producer of oil, closely followed by Iraq and Iran, and also the United Arab Emirates and Kuwait and places like that. So this entire region has benefited from being an ancient seabed. So the area that is now the Arabian Peninsula was once under the sea, and that's part of the reason why it has so much oil resources. It is also a very unfortunate fact of history that the Middle East has been invaded on multiple occasions in multiple different supposed reasons. But one of the main things that comes out of those repeated invasions of Iraq and Iran, including the UAE and Saudi Arabia, in sort of a bit further back in the past, actually one of the things that's happened is that big transnational companies based in the countries that were doing the invading, like the United States, Britain and France, have actually got the contracts to extract the oil. And so some of the profits that come from all that oil extraction is going into the hands or the pockets of big oil companies like ExxonMobil, British Petroleum and Shell in European and Western nations. So a bit concerning there. So we're going to think a bit about coal now. Coal reserves, so we were just talking about reserves. They are what is still remaining in the ground. Coal reserves are not very evenly distributed. In fact, just 5 or 6 countries have the vast majority of coal reserves, the coal that is remaining on the planet. So the United States has 28% of it, over a quarter of it, and Russia and China have very large coal reserves as well. Now, whether we want to take coal out of the ground is a good question because it is one of the most dirty and polluting fossil fuels we can use. And many countries are trying to move away from coal. But first, before we talk about moving away from coal or using it or not, I'm going to ask you just quickly about how you think just a few countries ended up with so much of what is there. Why is it not spread out all over the planet? Well, the reason for this is similar to the oil example. Coal was formed from the decaying of ancient forests that covered huge parts of the earth. And as those trees died and decayed and they got covered in soil, layers upon layers, pressing and compressing it formed coal. And that's those hydrocarbon chains in all living things, including you and I, just like an amino acid hydrocarbon chain, okay, which provide the fuel that we use to burn, okay? So another cartogram, this time for coal, and you'll see that there are much fewer countries because, as we've already mentioned, the coal that remains on the planet, although there's quite a lot of it, is really concentrated in just a few places. So pretty much the whole of Africa appears to disappear. Pretty much the whole of South America has disappeared. Even most of Canada is gone. And the 3 countries that are really large on here are the USA, India, and China. Now, other places nearby, Indonesia and Australia have quite large coal reserves and they are extracting it. Now, one of the things that we'll notice about the countries that are keen to use coal and continue to do so, despite the fact that it's incredibly dirty, is actually that they tend to be developing countries. They tend to be slightly poorer than the kind of countries that are able to afford to switch to oil, gas, and renewables. Now, that is not strictly true. It's also because coal being very cheap, if you want to ramp up the amount of energy you're using, if you want to expand the amount of energy you're producing very quickly, coal is an easy way to do that. And so both India and China, having large populations with improving qualities of life, have expanded their coal production in order to meet the very high growing demand for energy. So China has an odd relationship with coal, an interesting relationship with coal, because overall across the world, the amount of coal that we're using is in decline. It's going down because it's so dirty and polluting, but China still produces almost half, 45% of the world's coal. And although it is producing a huge amount of coal, almost half of the global amount ever, it is still producing less energy from coal than it used to. So in 2011, coal made up 70% of the energy that China consumed. But by 2018, so just 7 years later, it had fallen to just 59%. And it continues to go down. So if we were to mix up all the different types of energy that China was using, from hydro, wind, coal, oil, nuclear, everything, the amount of coal in that pie chart would be getting smaller, but actually the overall amount of coal that's being used is remaining the same. And this is a bit confusing, but that's basically to say that the pie is getting bigger. So although the width of the slice of the pie is getting smaller, the overall amount of coal being used, or the slice of the pie size, is the same. So these countries that are still top producers of coal are largely developing countries: India, China, Indonesia, Russia, South Africa. A few oddballs in there: Australia, because they can sell it so easily. Germany as well, perhaps a surprising one, because they have quite green credentials otherwise. So what I'm going to ask you to do now is a little bit of research. You've been listening to me talk for quite a while, so we're going to pause for about 10 minutes. You're going to do a bit of research for me, and I'd like you to find out how these three factors: geology, which is rock types, relief and climate, the height of the land or the shape of the land, and the climate that we have in that place, the average temperature and precipitation, and the accessibility and development of a place, how easy it is to get in and out of, and the development level, economic development, affect the amount of energy available in a country. So if we're talking about, for example, coal, the geology is really, really important, because there's no access to coal if it just doesn't exist under the ground. Again, oil is quite similar, but maybe oil and gas are a bit more plentiful and spread out. If we were thinking about perhaps wind or solar energy, climate is going to be really important. So take a few minutes, pause the video, and do this research for me, please. Okay, so I've got a couple of answers here for you, but I hope that you found that research interesting. Generally, we find fossil fuels in sedimentary rocks. I did mention this earlier, those layers and layers of compressed rock that come from the sediments that flow into the sea. Okay, relief and climate is a big one in terms of rainfall and suitable relief needed for hydroelectric power. We tend to put large dams for hydroelectric power in mountainous regions and steep-sided valleys. In some places we find high wind speeds offshore, and we're going to talk about that next. Particularly in the UK, having high wind speeds just off our coastlines can make the sites of these sites ideal for wind farms. And of course, if you want to think about what we can do in the Sahara Desert to generate energy, I do hope that you've come up with the idea that maybe it's a good idea to have solar energy. Accessibility and development is an interesting one. It's really important because it tells us how much money people are going to put into energy resources. The Sahara Desert might be fantastic in terms of the amount of solar energy it receives, but if we think about the countries that are on the Sahara, how many of them do big transnational companies, TNCs, want to invest in? Might they not trust it? Or even if they do trust it, will they be able to hire people with the right expertise? Do they have people who can speak the right languages? So there's, for example, in Africa, fantastic renewable potential, but not many people who are willing to invest in developing that potential. And that is, a great shame, but it is a factor that is changing who has access to different types of energy. So some resources are in fact found in remote or difficult to reach areas. And this is something we're going to talk about, as I said, when we talk about oil in unconventional extraction methods, where we find energy in places like the Arctic and we're trying to get it out, and what problems that causes. So we're almost at the end. Our next task, as with almost all the tasks in today's lesson, are about data and graphs. This graph here is showing us investment in renewable energy by the type of technology. It's what we would call a compound bar graph, because each bar is the total amount of money that was put into new energy resources. Now, this is not about how much energy was created from these resources. This is about how much people are spending on creating them. So, for example, if you put up a brand new wind farm and it costs billions of pounds, then that would be a huge investment in wind energy, and it would come up in this kind of light green color. So we've got 3 questions and a challenge to answer on this graph, and we're going to have a moment to just look at the graph clearly. Okay, so this compound bar graph, the bars themselves are growing, so the overall total of investment is growing over time for most of the time. But in addition, each of these bars is broken up into the different sections of which type of energy it is. So the 2 most popular types of renewable energy on this graph that people are investing in are what? They're the 2 green ones, and if we use our key, it is wind and solar energy. So wind and solar energy are the 2 most popular types of renewable energy to invest in. Which type of renewable energy is becoming less popular to invest in? So what we're looking for here is something that is shrinking in size, even though the overall bar is getting bigger. So you can see this bar is bigger than this bar, and this bar, and this bar is bigger than that one. And they get bigger over time, but some of these sections is decreasing. So for example, here, the red one is quite large. Oh, bless me. Weird. Okay, sorry. Here you can see that the red and orange section is decreasing. Now, that is for liquid biofuels and small hydropower. And of course, the yellow one as well, biomass and waste energy. So these have been decreasing in size, and that shows that less people are willing to put money into these types of energy. So when we talk about that, what do we mean? Well, a liquid biofuel is a fuel that is made from living things, and in particular we make it from crops. So the most common kind of crop is ethanol, or the most common fuel is ethanol, and the common crop to make it from is either corn or soybeans. Now, of course, both corn and soybeans are edible. You can eat them. So if I take a field full of corn that you could feed to somebody and I turn it into something you're going to burn in your car, some people consider it a massive waste of that food. So there's a couple of things to talk about here. We're saying that liquid biofuels like ethanol and biomasses are renewable, but they are not perfectly green, because although the plants grow and absorb CO2, when you burn the fuel, you are releasing that CO2. So they're renewable, but they still release CO2 when they're burnt, which is not necessarily the ideal thing. We want something that's completely green. Ethanol is also controversial, as I've said, because it uses crops to produce, which is expensive. And then the fuel, instead of you're using the fuel, you're burning the fuel instead of using the crops that you could have used to feed people. Now, something that's very common when they give you a graph in a geography exam is that they ask you to do a small calculation. So I'm going to ask you to do, percentage change in solar investment between 2014 and 2015. Now, the numbers have been given to you up here. Okay, so solar investment being the dark green colour. And in 2014, that was $144 billion. In 2015, that investment in solar energy had grown to $172 billion. What is the percentage change between 2014 and 2015? You're going to need to pause the video now to answer that question. Okay, so the answer to that question is a 19.4% increase in the amount of energy. And this is how we would work that out for those of you that are feeling a bit spotty on your maths today. So to calculate percentage change, we need to know what the difference is between our two figures. So we've got 172 minus 144, which gives us 28. 28 is the quantity of the change, and we're going to divide that by the original figure to calculate what the percentage increase was. So we've got 28 divided by 144, which gives us 0.1944 recurring. And to turn that into percentage, we just need to times that up by 100, and that gives us 19.44 recurring percent. But we'll round that up and make it 19.4. Finally then, my challenge question: why did investment in renewable energy fall between 2011 and 2013? Why is there this dip here in the amount of money that companies are spending on renewable energies? What could have happened? Well, I hope that you already have heard of, but if you haven't, then this is a good chance to remind ourselves. There was a global financial crisis in 2000 and, in 2009 was the main global financial crisis, but then there was a kind of an extra bit that happened in 2010 and 11. And it led to a fall in demand for pretty much most goods and services. So anything that we were importing from China was reduced in demand, less things were being exported from China. And that meant that even China needed less energy, and incomes were falling. And that means that companies had less money to spend or invest in new projects. So there were 2 or 3 consecutive years of declining investment in that period. It might be that in today's crazy world with coronavirus, we might see a similar impact on investment. So we're going to look now at wind energy production. And here's our top 10 for wind energy. We've got our top 10 countries for wind energy, and perhaps a surprise to you, I wonder, is that China is by far and away the largest producer of wind energy. In fact, although China is the largest producer of coal energy and the largest consumer of gas energy as well, it is also the largest consumer of wind energy. And this is kind of a way of showing that they just use tons and tons and tons of energy. And in our first graph where we said, well, they use less than the US, you have to remember that that was per person, per capita. They're followed by the United States, Germany, Spain, India, and the United Kingdom. And one thing that we notice when we look at this map, and this is a map, and there's a link down here to the Global Wind Atlas. Now, the Global Wind Atlas shows us, when it loads, it shows us where there is high potential for wind energy. It's working. Okay. So this is the Global Wind Atlas, and it shows us where places have high potential for wind power. So what we'll notice is, if you can see the scale on the side here, and there's a little arrow, and that arrow is going to move up and down depending on where I hover over. So if I look down here, you've got quite a still, calm environment. In fact, this is in the Congo rainforest, and there are not very strong winds there. Really you get very heavy convection rainfall. The water evaporates straight up, forms clouds, or falls straight back down again. There's not a lot of strong winds there. Whereas as we get towards the edge of the Hadley cell, we do get strong winds, and you can see up here on the right hand side the little arrow is moving up. So these dark red colours, again, because this is a chloropleth map, are showing very strong wind potential. Now, just to draw your attention, why is it we don't want to put a wind farm out here in the middle of the ocean? Well, the answer to that is not that there's no strong wind, okay? There may be strong wind, but if it is that far away, over very rough, choppy seas, actually transporting the energy from here back to the land is going to be really difficult. So the best places for this are places that are close enough to the shore that we can get the energy back to land and not too far away. So if we want to explore a bit more, here's China, and you can see that China's offshore potential for wind is very strong. Also in these inner regions here, in China's sort of high Mongolian plains and stuff like that, good places for wind. Let's go back. So in your worksheet, you are answering just 2 questions, and there's another 3 on my next slide. So where in the world is there high potential for wind energy? Where did we say? Okay, yes, it is the areas with dark colours, but you need to actually name them. Okay, so in particular, the UK and the North Sea looks really strong. Coastal regions tend to be very good for wind energy, and that includes, say, for instance, islands. And I want to ask you, are the places that have high potential the same places with the top producers? Well, China had some high potential, but it isn't really that's what's caused it. And when we looked at the USA, there wasn't that much high potential. So clearly, for somewhere like the United Kingdom, where there's loads and loads of high potential surrounding it, they're not really using it that much. So here I have a similar map for solar energy. And this one's even stranger. Of course, near the equator and in our subtropical regions where we would find deserts, somewhere like Australia, super hot, the Sahara, as we've mentioned, Mexico and the southern parts of the United States have very high potential for solar energy. But when we look at our top 10 solar countries, we're seeing Germany as the largest producer of solar energy, despite the relatively low amount of light energy that they receive. Although it's more than enough to power things, the solar panels work, they're just not producing as much energy as we could do if we put them somewhere even better. Again, China appearing very high on this list because they have such a high demand for energy that any route to getting it is great, and something that's not going to run out sounds like a much better plan. They're investing in sustainable energy sources as well as the dirty, polluting coal. They're doing both, and that's a really interesting point to make. So often we say, oh, the rich country's doing this, the poor country's doing that, and we want to just divide things into 2 categories. In this case, China's doing it all. They're doing the green energy sources, they're doing the dirty, polluting energy sources, they're doing anything they can to raise enough energy for their very high demand. Perhaps another surprise entry, Japan, but when you think about the high levels of technology industry that they have there, it makes sense that they have access to the technology that would provide you with lots of solar energy. And then almost all these countries, you'll notice, up until number 10 with India, are all developed countries. They're pretty much all wealthy and developed. Now, some of these are countries that we have discussed before, but others are ones we haven't. Let's take Japan again as an example. Japan has almost no fossil fuel energy resources whatsoever. Everything that they either have to buy in or they have to go down the renewable route. And because they don't have anything that they have of their own, and they have to purchase it from other people, they are very keen to be able to develop alternatives. So Japan is producing lots of solar energy because they need alternatives. The other one that Japan is quite interested in, or has been for a long time, is nuclear energy, and that's a whole nother can of worms in terms of controversy. Guys, last two questions then. Are the countries that are currently producing large amounts of solar energy, do they have anything in common? We said that they were wealthy nations, that they were developed nations. Number 5, are they the places with the most potential for high levels of solar energy production? Unfortunately, the answer to that is no, they're not. The places that have high potential for solar energy production, maybe apart from the United States, but somewhere like Mexico, Australia, has a little bit down here in number 9, South Africa, and these Saharan countries, so Algeria, Libya, Morocco, Egypt, Niger, Chad, Mali, all of those countries are not actually using it. And this really comes down to that point we looked at earlier about both accessibility and development. While those countries are not as developed in terms of their infrastructure, in terms of their factories, in terms of their education system to have people who have the right skills to do these jobs, these industries will struggle to develop. Guys, this has been a long lesson, I know, but thank you for persevering with it. I hope that you've found it interesting, and I will see you next time.